Everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter some basic concepts of chemistry. So any doubts if you have in any steps of the solutions, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Um, Also, in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that 1.78 gram of an optically active L amino acid A is treated with this L amino acid is treated with NaNO2 HCl at 0 degree Celsius and N2 gas is obtained at STP, and it is told that at STP if 1.78 gram of this L amino acid is used, then 448 centimeter cube of nitrogen gas is obtained at STP. A sample of protein. So here we have a sample of protein. So here it has got 0.25 percentage of this L amino acid by mass. So it means that 0.25% of the mass of the protein, the mass of the protein has this L amino acid. So then we have to calculate the molar mass of this protein. Okay. So here, um, so from here we can say that 1 mole of L amino acid, 1 mole of the L amino acid will react to give 1 mole of L amino acid gives 1 mole of nitrogen gas into gas at STP. So now here 448 centimeter cube is how many moles of N2 gas that we have to find. Since we know that the rule is that 1 mole of an ideal gas means 1 mole of N2 gas will occupy 22,400 centimeter cube of N2 gas. So therefore we can say therefore 448 centimeter cube of N2 gas. It means that it is 448 divided by 22,400 mole. It means we can say it is 224 into 100 and this is 224 into 2, which is 0.02 mole of N2 gas. 0.02 mole of N2 gas. Now, so it means 0.02 mole of N2 gas will be obtained from 0.02 mole of L amino acid. Therefore, the mass of 0.02 mole of this L amino acid is equal to 1.78 gram. Therefore, the molar mass of this L amino acid, molar mass of this L amino acid, that will be equal to 1.78 divided by 0.02 gram. So this will be 178 divided by 2, which is equal to 2 8 is 16, 2 9 is 18, 89 gram. therefore the molar mass of this L amino acid is 89 gram. So now, therefore, 1 mole of this protein sample, we can say, it means, suppose we can say 100 gram, uh, is told. So here it is told that um, the mass of this protein sample means it has got 0.25 percentage of the mass of this protein has L amino acid. So therefore 100 gram of this protein sample has 0.25 gram of this L amino acid. L amino acid. So now therefore now we can say that 1 mole of the protein sample will have 1 mole of this L amino acid only. 1 mole of the protein sample has, okay, has 1 mole of this L amino acid. So therefore 100 gram of this protein sample has 0.25 gram of L amino acid. So therefore 89 gram of 89 gram of L amino acid, 89 gram of the amino acid will be in will be in um, so 0.25 gram is in 100 gram of the protein sample. So 1 gram of L amino acid will be in 100 by 0.25 gram of the protein sample. So 89 gram will be in this into 89 gram of the protein sample. So therefore, 1 mole of the L amino acid is there in 1 mole of the protein sample. So therefore, the molar mass of the protein sample, molar mass of the protein sample, that will be equal to 100 by 0.25 into 89. So 0.25 means 1 by 4. So it is 400 into 89 gram. So which is nearly 4 nines are 36. 4 is a 32, 35600 gram. So it's 35,600 gram. So option D is the correct answer. Then here it is told that 10 gram of mixture of 10 gram of uh, mixture of BaO and CO means 10 gram we have 10 gram of a mixture of barium oxide and calcium oxide. It requires um, HCl, which is 100 centimeter cube of 2.5 molar HCl. It requires to completely react. For complete reaction, it is required. Then the percentage of calcium oxide in the mixture is approximately. So let's suppose the calcium oxide present in the mixture is, let's say, X gram. That means since the total mass of the mixture is 10 gram only, so the barium oxide present is 10 minus X gram of the m- mixture. So therefore, the percentage of calcium oxide in the mixture, the percentage of calcium oxide in the mixture percentage of calcium oxide in the mixture, that will be equal to x by 10 into 100%. So that will be equal to 10x percent. So we have to find x first here. So here calcium oxide, so it means that the molar mass of calcium oxide, will be 40 plus 16, that is 56 gram, and molar mass of barium oxide, that is given as 153 gram. So now here we can use the law of equivalence, that calcium oxide will react with 2 moles of HCl, and barium oxide will also react with 2 moles of HCl to form BaCl2 and H2O, and CaO will also react with 2 moles of HCl to form calcium chloride and H2O, and barium oxide will also react with 2 moles of HCl, means 1 mole of barium oxide will react with 2 moles of HCl to form uh, BaCl2 plus H2O. So therefore, now we can say the number of moles of HCl, required, that is twice of the number of moles of calcium oxide plus twice of the number of moles of barium oxide. So now x gram of calcium oxide we are having, and 10 minus x gram of barium oxide we are having in the mixture. Therefore, the number of moles of calcium oxide, that will be equal to x by 56, and the number of moles of barium oxide, that will be equal to 10 minus x by 153. Now therefore, and the number of moles of HCl that is being used, that is this, that will be molarity times the volume of HCl in liters. So here the molarity of HCl, that is given 2.5 molar, and volume of HCl is 100 centimeter cube. It means 0.1 liter. It will be 0.25 mole. 0.25 mole of HCl is used. So therefore, we can say 0.25, that will be equal to 2 into x by 56 plus 10 minus x by 153. Now this we can solve to find x. We actually have to find 10x. 10x percent is the answer actually. We have to find the value of that 10x actually. Okay. So here, therefore, 0.25 means 1 by 4. So I can say 1 by 8 is 153. Okay. 1 by 8, that is equal to x by 56 plus 10 minus x by 153. Therefore, we can say this will be we can multiply. Okay. This will be 1 by 8, and if you take LCM here, this will be 153x plus 560 minus 56x, that is divided by 56 into 153. 7 8 is 56. So therefore, we can say 153x minus 56, that is equal to 3, that will cancel. That is 97x, 3x, 97x plus 560, that is equal to 153 into 7. Yeah. So therefore, x will be equal to 153 into 7. So 3 7 7 3 are 21. 30. 537, 707, 1071 minus 560 divided by 97. So therefore, required percentage of calcium oxide in the mixture that is equal to 10x percent, as we have found it, 10x percent, since it is x by 10 into 100. So that will be equal to 10 into 10 into this will be 1, we subtracted 1, 1 and 5, 511 into 10 by 97. So that is approximately 500, 5110 divided by, so that is approximately 52.68%. So option A is the closest answer. Option A is the correct answer. Then here it is told that 25 centimeter cube of oxalic acid. Oxalic acid means oxalic acid, as we know, that is equal to COH whole twice, or we can write it as H2C2O4. So 24 centimeter cube, 25 centimeter cube of oxalic acid completely neutralized sodium hydroxide, 0.064 gram of sodium hydroxide. So hence it will react with 2 moles of NaOH to form Na2C2O4 plus 2H2O. So here, therefore, here we can use the law of equivalence, which is the number of milliequivalents, the number of milliequivalents of the acid, which is H2C2O4, that is equal to the number of milliequivalents of the base. Number of milliequivalents of the base. Which is NaOH here. Now the number of milliequivalents is the number of millimoles of the oxalic acid H2C2O4 times the valency factor of H2C2O4 is equal to, and here the valency factor of oxalic acid will be obviously 2, since why it will give 2 H plus ions, and the valency factor of NaOH, that will be equal to 1, since why it will give only one hydroxyl ion. It will give only one OH minus ion. So therefore here the valency factor of this oxalic acid is 2, and that is equal to the number of millimoles of NaOH, number of millimoles of the sodium hydroxide NaOH times the valency factor of NaOH, which is 1. Now the number of millimoles of H2C2O4, that is equal to the molarity of H2C2O4, which you have to find out, times the volume of H2C2O4, the volume of the oxalic acid in milliliter or in centimeter cube. So as you know, 1 centimeter cube is 1 ml, so it is 25 ml. So this into 25, since we know that the number of millimoles, that is given as number of millimoles of any substance, that is equal to molarity times the volume in centimeter cube or in ml. So it is m into 25 into 2, that is equal to the number of millimoles of NaOH, that is equal to, and number of millimoles, that is also equal to the number of moles into 1000. Number of moles into 1000. Since why 1000 millimole, that is equal to 1 mole. So the number of millimoles of NaOH, that is equal to the given mass divided by molar mass of NaOH, Now the molar mass of NaOH, that is molar mass of NaOH, that is equal to mm, that is equal to 23 plus 16 plus 1, so 17 plus 23, that is equal to 40 gram. So this divided by 40 into 1000. So therefore, into 1000 means it will become 64. Therefore, it is m into 50, that is equal to 64 by 40. So therefore, it will be 4 tens of 44, 16 4 is 64. Then molarity into 50, that will be equal to 16 by 10. Molarity equals to 16 by 500. It will be 32 by 1000. So that will be equal to 0.032. So therefore, option D is the correct answer. Then here it is told 0.30 gram of an organic compound containing C, H, and O. So it contains C, H, and O. So it is of the form, I can say C, N, H, M, and O, P, suppose. So N number of carbon atoms, M number of hydrogen atoms, P number of oxygen atoms. So it is an organic compound. So in this form it is. So it contains only carbon, hydrogen, and oxygen. And 0.3 gram of this organic compound on combustion, it yields 0.44 gram of carbon dioxide. So it means if I have CnHMO, yeah, so here 0.3 gram of this compound with its combustion with oxygen, that will give 0.44 gram of CO2, and it will give 0.18 gram of H2O. So here it is told 1 mole of the compound weighs 60 grams. So it means that the molar mass of the compound, or you can say the, yeah, molar mass is of the organic compound, that is 60 gram. So then the molecular formula of the compound has been asked. So here, so now the molar mass of CO2. So now here 0.3 gram of this organic compound has been re- reacted with oxygen, which is the combustion reaction. So it means that 0.3 gram of this organic compound, that will be equal to 0.3 by 60 mole, which is equal to 3 by 600, which is 1 by 200 mole. So now 1 by 200 mole of that compound, now 0.44 gram of CO2. It means that now we know that molar mass of CO2, that is 44. So it will be 0.44 divided by 44, which is 0.01 mole of CO2. And 1 by 200, it means that it is 0.005 mole. And also 0.18 gram of H2O, 0.18 gram of H2O, it means that it is 0.18 by molar mass of H2O, that is 18 gram. So this much mole, that is equal to 0.01 mole of H2O. So it means that here the organic compound, which is 0.05 moles of the organic compound gives, or it produces 0.01 mole of CO2 and 0.01 mole of H2O, which means I can say that 1 mole. So it means the mole ratio of carbon and oxygen in it, the mole ratio of carbon and carbon and hydrogen. So 0. So it will be 1 is to 2. Since why it will be 0.01 is to 0.02. Since why 0.01 mole of H2O will have 0.02 moles of hydrogen atoms, and 0.01 mole of CO2 will have also 0.01 mole of carbon atoms. So therefore it is 1 is to 2. The mole ratio of carbon and hydrogen is 1 is to 2. Mole ratio of carbon and hydrogen is 1 is to 2 in the compound. Therefore, here 0.05 mole will give 0.101 mole of CO2. So it means that 1 mole of the organic compound will give 2 moles of CO2, and also it will give 2 moles of H2O, which means that 1 mole of the compound it has 2 moles of carbon atoms and 4 moles of hydrogen atoms. So therefore the formula, the molecular formula of the organic compound, that will be C2H4O. C2H4O, and since C2 and oxygen can be any, the number of oxygen atoms, so C2H4 is in option B only, so it should be C2H4O2 only. So it means that option B is the correct answer. Or we can also find out the number of oxygen atoms like this also. Uh, simply we can say that, yeah, carbon means here the compound which we have, 1 mole of that C2H4, let's say oxygen, the number of oxygen atom is P, so that will react with oxygen to give CO2 plus H2O, means 2 moles of CO2 and 2 moles of H2O. So here the number of oxygen atoms is 2 twos of 4, 4 plus 2, 4 plus 2, that is 6. So here I can have 3 O2s, then here P will be 0, but here P cannot be 0. Okay. So here we can take 2 oxygens and here P will be 2 then. And we can also find out by using the molecular weight also. For C2H4, for 2 carbons, okay, suppose here we take 2 carbons. So we have C2H4 and OP. We have to find out the number of oxygen atoms. Here the molar mass will come as 12 twos are 24 plus 4 plus P into 16. And that should be equal to 60. Now from here we can find out P. So it will be 16P, that is equal to 60 minus 28. So 16P, that is equal to 2, and this is 3, this is 32. So P will be equal to 2. So P should be 2. So it should be C2H4O2. So by using the molar mass also we can find out the number of oxygen atoms in one molecule of that organic compound. So then here it is told that what amount of dioxygen in gram contains 1.8 into 10 power 22 molecules. Now 1.8 into 10 power 22 molecules, it means it is 1.8 into 10 power 22 divided by 6 into 10 power 23 moles. That is equal to 6 3 is 18. 0.3 into 10 power minus 1, that is 0.03 mole. Now, so it means that 0.03 mole of O2 molecules we have. Now, therefore, mass of 1 mole of O2 molecules, that is equal to the molar mass of oxygen, that is equal to 32 gram. Now, therefore, the mass of 0.03 mole of oxygen molecules, that will be equal to 32 into 0.03 gram. So that will be equal to 3 2s are 6, 3 3s are 9, so it is 0.96 gram. So it means that option A is the correct answer. So hope, okay. So hope you have understood, and still any doubt if you have, please write us in the comments. Okay, so here It has been told that the number of oxygen atoms in 4.4 gram of CO2 is. So the molar mass of CO2, that is equals to, we know that 12 plus 32, that is equals to 44 gram. So now therefore 4.4 gram of CO2, it means that we have 4.4 divided by, so given mass by molar mass, that will give you the number of moles. So that is 0.1 mole of CO2. So now therefore, now one molecule of CO2 contains two atoms, two atoms of oxygen. Now therefore, so I can say that 0.1 mole of CO2, 0.1 mole of CO2 will contain 0.2 mole of oxygen atoms. 0.2 mole of oxygen atoms, which means that is 0.2 into Avogadro number, that is 6.6 into 10 power 23 atoms of oxygen. So that is 6 to the 12. So that is 1.2 into 10 power 23 atoms. So it means option A is the correct answer. Then here it is told an organic compound contains carbon 40%, hydrogen 13.33%, and nitrogen 46.67%. Now, um, so therefore I can say that suppose we take 100 gram of that organic compound. So 100 gram of that compound, 100 gram of that organic compound contains 40 gram of carbon, 13.33 gram of hydrogen, and 46.67 gram of nitrogen. Now, therefore, 40 gram of carbon, it means that we have 40 by 44, sorry, carbon, molar mass of carbon, that is 12. So 40 by 12, that is approximately 3.33 mole of carbon. Now 13.33 gram of hydrogen, that means it is 13.33 mole of hydrogen, since the molar mass of hydrogen is 1 gram. And then 46.67 gram of nitrogen means it is 46.67 divided by 14, which is also approximately 3.33 mole of nitrogen. So now uh, therefore the molar ratio, the molar ratio of carbon, hydrogen, and nitrogen in the organic in that organic compound that will be equal to 3.33 is to 13.33 is to 3.33. Now 13.33 I can tell approximately it is 3.33 times 4. And 3.33 times 4, it is 4 3 12, 4 3 12, 13, 4 3 12. Okay. It is 13.33 approximately. So this molar ratio, we can say it is approximately 1 is to 4 is to 1. Therefore, the ratio of carbon, hydrogen, and nitrogen, carbon, hydrogen means the number of carbon, hydrogen, and nitrogen in that organic compound is 1 is to 4 is to 1. So therefore, formula, the empirical formula of the organic compound is is C is CH4N. CH4N. CH4N, that is option C is the correct answer. Then here it is told if 3.01 into 10 power 20 molecules are removed from 98 milligram of H2SO4, the number of moles of H2SO4 left are. Now we have to find the molar mass of H2SO4. Molar mass of H2SO4, that will be equal to 2 plus, for sulfur it is 32 plus 4 into 16, that is 64. So 64 plus 34, that is equal to 98 gram. Now therefore 98 milligram of H2SO4, it means that we have 98 into 10 power minus 3 gram divided by 98 gram. So that is approximately 10 power, so which is equal to 10 power minus 3 mole of H2SO4. It means how many molecules do we have? So, or here it is told that 3.01 into 10 power 20 molecules have been removed. It means these many molecules, it means 3.01 into 10 power 20 divided by the Avogadro number, that is 6.02 into 10 power 23. So this much moles of H2SO4 has been removed. This much mole of H2SO4 has been removed. So this value is approximately 3.01 into 2 is 6.02. So it is half into 10 power minus 3. So which is approximately 0.5 into 10 power minus 3. That has been removed, this much mole. Therefore, the number of moles left, number of moles of H2SO4 left, that will be equal to 10 power minus 3 minus 0.5 into 10 power minus 3. So that is also 0.5 into 10 power minus 3 moles. So this much mole of H2SO4 are left. So option A is the correct answer. Then here it is told that 1 gram of Mg is burnt. 1 gram of Mg is burnt with 0.28 gram of, okay, 1 gram of Mg is burnt with 0.28 gram of O2 in a closed vessel. Which reactant is left in excess and how much? So it will form MgO, magnesium oxide. And here it should take 2 Mg. So therefore 2 moles of Mg will react with 1 mole of oxygen. Now therefore the molar mass of magnesium, molar mass of Mg, that is equals to 24 gram, and molar mass of oxygen gas, that is equals to 32 gram. Now therefore 1 gram of Mg, 1 gram of Mg means we have 1 by 24 moles of Mg, and 0.28 gram of oxygen. That means that is 0.28 divided by 32 mole of oxygen, of oxygen gas. So that will be 28 by 3200. So 4 7s are 28, 4 8s are 32. So 7 by 800 mole of O2. Therefore, oxygen is present in lesser amount. Therefore, now 7 by 800 mole of O2 will react with 1 mole of O2 reacts with 2 mole of Mg. So 7 by 800 mole of O2 will react with 14 by 800 mole of Mg, which means that is 2 7s are 14, 2 4s are 100, 2 4s are 8. Okay, so 7 by 400 7 by 800 mole of Mg. So 700 mole, 7 by 400 mole of Mg will be reacted, and therefore the remaining amount, therefore the amount of Mg that is left, the amount of Mg that will be left, that is equal to 1 by 24 mole. Out of 100, 1 by 24 mole, 7 by 400 mole has been reacted. So this much mole will be left. And and if we want the amount of mass that is left, so that will be 1 by 24 minus 7 by 400 into 24 mole into 24 gram. So that will be equal to 1 gram minus 7 into 24 by 400 gram. So that will be 4 6 24, 400 okay. So this is 1 gram minus 7 6 42, 0.42 gram. So that will be equal to 0.58 gram. So 0.58 gram of Mg will be left. So option B is the correct answer. Then here it is told that the mass of AgCl precipitated when a solution containing 11.7 gram of NaCl is added to a solution. Mass of AgCl precipitated when a solution containing 11.7 gram of NaCl is added to a solution containing 3.4 gram of AgNO3. Okay, so it will form AgCl, which is white colored precipitate. What precipitate would be formed? AgCl plus will form NaNO3. NaNO3, okay. So here 1 mole of NaCl will react with 1 mole of AgNO3. Now therefore the molar mass of NaCl, that will be equal to 23 plus 35.5, that is equal to 58.5 gram. 58.5 gram. And the molar mass of molar mass of AgNO3 silver nitrate, that is equal to the atomic mass of silver is 108 plus nitrogen, that is 14 plus 3 into 16, that is equal to 108 plus 14 plus 6, 16 3 are 48. So that is equal to, so this is 122 plus 48. So that will be equal to 120 plus 150, that is 170 gram. Now therefore 11.7 gram of NaCl, that means we have 11.7 divided by 58.5 mole of NaCl. So that will be equal to uh, 35. So this will be into 5. So 1 by 5 mole, that is 0.2 mole of NaCl. And then so here it is told that okay, then so 11.7 gram of NaCl is equal to 0.2 mole of NaCl, and then 3.4 gram of AgNO3, that will be equal to 3.4 divided by 170. So that will be equal to 34 by 1700 mole, that is 1700 17 twos are, so that 1 by 50, that is equal to approximately 0.02 mole of AgNO3. So it means that AgNO3 is the limiting reagent. Since why here we have 0.02 mole of AgNO3, that will react with 0.02 mole of NaCl, and here we have got 0.2 moles of NaCl. So after reaction, 0.2 minus 0.02 mole of NaCl will be remaining. So that will remain unreacted. So it means 0.02 moles of AgCl will be formed. So therefore, mass of AgCl silver chloride that is precipitated that is precipitated that is equal to 0.02 moles of AgCl, and the molar mass of AgCl will be 108 plus 35.5 gram. So that will be equal to 0.02 into, this will be 143.5 gram. That will be equal to 2 5s are 10, and 2 3 are 6, 7, because 8, 1s are 2, and be 0.287 gram. No, sorry, it will be 2 5s are 10. It will be 2.87 gram. 2.87 gram will be precipitated. So option C is the correct answer. Then here it is told 0.4 gram of dihydrogen, 0.4 gram of dihydrogen means H2 is made to react with 7.1 gram of dichlorine, that is Cl2, to form hydrogen chloride, HCl. So it will form, so here the reaction is actually H2 plus Cl2 gives H2HCl. The volume of hydrogen chloride formed at 273 Kelvin and 1 bar pressure is. So here we have to use the rule. The rule is that 1 mole of any ideal gas, 1 mole of any ideal gas occupies 22.7 liter 22.7 liter at NTP, where NTP means, which is at 273 Kelvin and 1 bar pressure. NTP means normal temperature and pressure. Now, 2 moles of HCl will be formed here. With, if 1 mole of H2 reacts with 1 mole of Cl2, then 2 moles of HCl is formed. Now, molar mass of H2, molar mass of hydrogen, that is, we know that is equal to 2 gram, and molar mass of Cl2, that will be equal to 71 gram. Now, therefore, 0.4 gram of H2, that means we have 0.4 by 2, that is equal to 0.2 mole of H2. And similarly, 7.1 gram of chlorine, that means we have 77.1 by 71, that is that is 0.1 mole of Cl2. So it means that here chlorine is the limiting reagent. Here we have 0.1 mole of chlorine and 0.2 moles of hydrogen. So it means that 0.1 mole will remain unreacted and 0.1 mole will react to form 0.2 moles of HCl. Now, therefore, the volume of 1 mole of HCl, 1 mole of HCl at NTP, that is 22.7 liter, and so the volume of 0.2 moles, 0.2 mole of HCl at NTP, that will be equal to 22.7 into 0.2 liter. So that will be equal to, so the 14, the 4, 5, the 4, so 4.54 liters. So it means option A is the correct answer. Then here it is told a gas mixture contains 25% of helium and 7 point uh, and 75% CH4 by volume at a given temperature and pressure. A gas mixture is there. It contains 25% helium and 75% methane, 75% CH4 by volume at a given temperature and pressure. So it means the temperature and pressure, these are kept constant. The percentage by mass of methane in the mixture is approximately. So here, this is the percentage by volume. Then what is the percentage by mass of methane that is being asked? So here, suppose we take the total volume that is equal to 100 ml, suppose 100 ml, suppose. Therefore, the volume occupied by helium, volume occupied, or simply we can take, okay, the volume, okay, the volume occupied by helium that will be equal to 25 ml, and volume occupied by methane that will be equal to 75 ml. Then 75% of the volume is occupied by methane. Now, therefore, um, we know that PV equals to nRT, PV equals to nRT. Now, therefore, here pressure and temperature are kept constant. So volume is proportional to N. Volume is proportional to N. It means the volume ratio is same as the molar ratio. Therefore, the molar ratio, molar ratio, which means the number of moles of helium is to the number of moles of methane, that will be equal to the volume occupied by helium is to the volume occupied by methane. So that will be equal to 25 is to 75. So that is equal to 1 is to 3. Now, therefore, number of moles that is given as the given mass divided by m- molar mass. Given mass divided by molar mass. Now, therefore, here it has been asked to find the mass of helium. No, the percentage by mass of methane. So, therefore, we have to find the mass of CH4 divided by the mass of CH4 divided by the total mass of the mixture into 100%. This we have to find. It means here now mass of methane by the molar mass of CH4 is to the mass of helium by the molar mass of helium, which is equal to the number of moles of methane is to the number of moles of helium. That is equal to 3 is to 1. That will be equal to 3 is to 1. Now, therefore, the mass of CH4 divided by molar mass of CH4 is 12 plus 4, that is 16, is to mass of helium divided by the molar mass of helium, that is 4. So that is equal to 3 is to 1. Therefore, it means mass of CH4 divided by 16 divided by mass of helium divided by 4, that is equal to 3 is to 1. Therefore, which is, it means mass of methane by mass of helium into 4 by 16, that is equal to 3 by 1. So 4 4 is 16. So that is mass of methane by mass of helium, that is equal to 12 by 1. Therefore, the mass of methane by mass of helium plus mass of methane that we have to find. So that is equal to 12 by 12 plus 1. So that is equal to 12 by 13. Okay. So this mass of helium plus mass of methane is the total mass of the mixture, the total mass of the mixture, that is. So this value will come 12 by 13 into 100%. So that will be equal to approximately, so that will be approximately equal to 12 into 13 sevens are 91. 13 sevens are 91. Then again 90 will come. So 13 sevens are 91. Okay. So 12 sevens are 84. Then 12 sevens are 84. 92.4% approx. 92.4% approx. So it is option B is the correct answer. Then here it is told a pure compound contains 2.4 gram of carbon, 1.2 into 10 power 23 atoms of hydrogen, atoms, and 0.2 moles of oxygen atoms. So oxygen atoms. Then its empirical formula is okay. So now, therefore, the number of moles, the number of moles of carbon, it will be equal to 2.4 gram divided by the molar mass of carbon, that is 12 gram. So that is 0.2 mole of carbon. Then the number of moles of hydrogen atoms, that will be equal to 1.2 into 10 power 23 divided by 6 into 10 power 23. So that is also 0.2 mole of hydrogen atoms. Then the number of moles of oxygen atoms, that will be equal to 0.2 moles. Therefore, the molar ratio, of carbon, hydrogen, and oxygen, that is equal to 0.2 is to 0.2 is to 0.2, or we can say 1 is to 1 is to 1. So I can say the empirical formula of that compound, the empirical formula of that compound, that will be CHO. So option D is the correct answer. Okay. Then here it is told that 56 gram of nitrogen, 56 gram of nitrogen, 56 gram, and 8 gram of hydrogen gas are heated in a closed vessel at equilibrium. 34 gram of ammonia are present. So here we have ammonia which is formed. So here we need okay. The 2 moles of NH3 is formed from 1 mole of N2 and 3 moles of hydrogen. Okay. So 34 gram of ammonia are formed. The equilibrium number of moles of nitrogen, hydrogen, and ammonia will be. So it is told that at t equal to 0 means initially the ammonia is not formed. The number of the amount of mass of ammonia formed is 0, and at equilibrium 34 gram of ammonia is formed. Then what is the equilibrium number of moles of nitrogen and hydrogen here? So now we know that molar mass of nitrogen gas, that will be equal to 14 into 2, that is 28 gram. And then molar mass of hydrogen gas, that is equal to 2 gram, and the molar mass of NH3 gas, that will be equal to 14 plus 3, that is equal to 17 gram. So it means that here 2 moles of ammonia has been formed here. 2 moles of ammonia has been formed, since 34 gram means 2 moles of uh, ammonia. 34 gram of ammonia means 2 moles of ammonia. And then 56 gram of nitrogen means here also 2 moles of nitrogen. And 8 gram of hydrogen means we have 4 moles of hydrogen. So now 2 moles of ammonia is formed. So it means that 1 mole of ammonia has reacted. So it means 2 minus 1 moles will remain. And since 1 mole of ammonia has reacted to form 2 moles of um, ammonia, so 3 moles of hydrogen will be reacted. So 4 minus 3 moles of hydrogen will remain unreacted. Now, therefore, the equilibrium number of moles of nitrogen, hydrogen, and ammonia, that will be 1, 1, 1, and 2. So 1, 1, and 2 moles. That will be the equilibrium number of moles. Equilibrium number of moles. So option 1 is the correct answer. Then here it is told 4 gram of copper was dissolved. 4 gram of copper was dissolved in concentrated nitric acid, and then copper nitrate will be formed, as you know, CuNO3 whole twice, and it will give hydrogen H2. Then the copper nitrate solution on strong heating it gave copper oxide plus cupric oxide, it will give copper oxide, it will give, okay. So it means that equivalent weight of copper is, okay. So we know that the equivalent weight of copper, that will be equal to the molar weight or the molar mass of copper divided by the valency factor. Now here as we see that Cu is going to copper nitrate, so here it has to lose 2 electrons. It will lose 2 electrons. So therefore the valency factor for copper is 2. Is 2 only. So therefore so here 4 gram of copper is used. And here 5 gram of copper is formed. 5 gram of copper oxide is formed. So from 4 gram of copper, here it means here 1 mole of, so here suppose we don't know the molar mass of copper oxide. So then here as we see that 1 mole of copper forms 1 mole of copper oxide. Okay. So simply it means the number of moles of copper, that is same as the number of moles of copper oxide. Now, in 1 mole of copper oxide, it also has 1 mole of it also has 1 mole of oxygen atoms. So it will be also same as the number of moles of oxygen atoms. So therefore, here here 5 gram of copper oxide is formed. It means that 4 gram of copper, and here for oxygen it is 1 gram of oxygen has been formed here. So it means uh, 1 gram of oxygen, it means it is 1 by 16 mole of oxygen. So it means this, therefore we can say that the number of moles of copper, therefore the number of moles of copper that is same as the number of moles of oxygen, that is equal to 1 by 16. 1 by 16 mole. Therefore, here this 4 gram, this should be the mass of 1 by 16 mole of copper. So therefore, mass of 1 by 16 mole of copper, that is equal to 4 gram. Now therefore, molar mass of copper, therefore molar mass of copper, that will be equal to 16 into 4 gram, that is equal to 64 gram. And so therefore the equivalent weight of copper, that will be equal to 64 gram divided by 2, since the valency factor is 2. So that will be equal to 32 gram. So it means option 4 is the correct answer. Then here it is told a solution contains 1.2046 into 10 power 1.2046 into 10 power 24 hydrochloric acid HCl molecules in 1 decimeter cube of the solution. The strength of the solution is. So now we have to find the normality of the solution. So as we know, normality of the HCl solution, that will be equal to normality of HCl solution, that is equal to the molarity of HCl solution times the valency factor of HCl. Now valency factor of HCl is 1 only. Since why, it will give only one H plus ion, it will give. So valency factor is 1, and molarity of HCl, that we have to find. Now molarity of HCl, that will be equal to the number of moles of HCl divided by the volume of the solution. Now and volume of the solution in liter we have to use. Now we know that 1 decimeter cube means 1 liter of the solution. So therefore the volume is 1 liter only, and the number of moles of HCl, that will be equal to the number of molecules of HCl divided by the Avogadro number, which is 6.023 into 10 power 23. This much mole per liter, so it will be 6 2s are 12. So this will be 0.2. So this is 2 into 10 power 23 divided by 2, 10 and 10, okay, sorry, 10 power 23, this much mole per liter. So that will be 2 mole per liter. And so therefore the normality of the HCl solution, that will be also equal to the molarity times the valency factor. So 2 normal. 2 normal. So option 4 is the correct answer. Then here it is told the pressure and temperature of a 4 decimeter cube of carbon dioxide gas are doubled, then the volume of the carbon dioxide gas is. So 4 decimeter cube means 4 liter volume is there. And if we consider CO2 gas as an ideal gas, suppose, then we can say that PV equals to nRT, means pressure into volume equals to the number of moles times the universal gas constant or ideal gas constant times the absolute temperature. So now here it is told pressure and temperature are kept constant only. So volume is proportional to the number of moles of CO2 since pressure and temperature. Okay. So okay, no, pressure and temperature are not kept constant here. So the initial volume, that is n into r to t by p, and v final, that will be n into r into 2t by 2p. Since why here it is told the temperature is also doubled, means T goes to 2T, and pressure is also doubled, so P goes to 2P. So 2P is the final pressure. But here we can see that the final volume is also coming nRT by P, which is same as the initial volume only. So it means the volume will remain unchanged since the final ratio of temperature and pressure, the final ratio, that is same as the initial ratio. So so the final volume is same as the initial volume, which will also come as 4 decimeter cube only. So option 1 is the correct answer. Then here it is told when 50 centimeter cube of 0 to 0.2 normal H2SO4. So H2SO4 is mixed with KOH. Then the 2 moles of KOH, that will form K2SO4. That will form K2SO4 plus 2H2O. So now here 0.2 normal. Therefore, as you know, normality, that is equal to the molarity times the valency factor. Now, therefore, now for H2SO4, since it can give two H plus ions, so the valency factor for H2SO4 is 2, and for KOH, the valency factor will be 1, since why it can give only one hydroxide ion. Only one hydroxide ion it will give. Okay. So now, therefore, the normality, so normality of H2SO4, that is 0.2, that is the equal to the molarity of H2SO4 times 2, that will be equal, so the molarity is 0.1 only. But yeah, so therefore here the number of moles of H plus ions, that will be equal to the molarity, or the molarity of H plus will be 0.2 only, since why we have since 0.1 is the molarity of H2SO4, so the concentration of H plus ion will be twice of the concentration of H2SO4, since why one H2SO4 can give two H plus ions. So the number of moles of H plus, that will be equal to 0.2 normal times 0.05 liter. So that is 2 5s are 10. That is 10, so 0.01 liter. No, this much in mole per liter, and this is in liter, so it will be 0.01 mole of, this is mole per liter, 0.01 moles of H plus ion. And similarly, the number of moles of hydroxide ion, OH minus ion, that will be equal to 1 normal KOH, so will be 1 into 0.05, so that will be 0.05 moles. Now it means the number of moles of OH minus is higher, so H plus is acting as the limiting reagent. So it means 0.1 mole of H plus will react with 0.1 mole of OH minus, and so 0.04 mole of OH minus will not react, will unreacted. Remain unreacted. It means that 0.04 moles of KOH will remain unreacted and 0.01 mole will react. Now, therefore, we know that when 1 mole of OH minus ions react with 1 mole of H plus ion um, to give 1 mole of H2O, 1 mole of H2O, and here the 57.1 kilojoule of heat is liberated. Since by the enthalpy of neutralization, the heat that is evolved per mole, that is 57.1 kilojoule. Therefore, here 0.01 mole is reacted. So therefore, here the heat liberated, the heat that is liberated, that will be equal to 57.1 into 0.01 kilojoule. That will be 0.0571. No, sorry. It will be 57. So it will be 0.571 kilojoule. 0.571 kilojoule, or I can say approximately 571 joule. So option 2 is the closest answer. So option 2 is the correct answer. Then here it is told molarity of 0.2 normal H2SO4 is. So we know that normality, that is equals to molarity times the valency factor or n factor. Now for H2SO4, the valency factor or the n factor will be equal to 2 only, since it can give 2 H plus ions. Now here now therefore the normality, that is 0.2, that will be equal to molarity into 2. So molarity will be equal to 0.1. Molarity of H2SO4 will be 0.1 only. So option 4 is the correct answer. Then here it is told a commercial sample of hydrogen peroxide is labeled as 10 volume. Its percentage strength is nearly. So now hydrogen peroxide H2O2, it is labeled as 10 volume. It means 10 volume, it means that 1 liter of H2O2 will give 10 liter of oxygen. So the reaction is H2O2 will give H2O plus O2. So 2 moles of H2O2 will give 2 moles of H2O plus O2. So now 10 liter of O2 is formed. So here, So the rule is that 2 moles of H2O2 will give 1 mole of O2, 1 mole of oxygen. Now at STP, uh, the molar volume of oxygen, is 22.4 liters. Therefore, 10 liter of O2, 10 liter of O2, it means we have 10 by 22.4 moles of O2. Now, therefore, so 10 by 22.4 moles of O2, it means that it is 100 by 224 is 250, 2 into 250 is 100, and 2 into 112, and 225 is and 2 5 is 10, 6 is 12. Okay. So it is 25 by 56 mole of O2, and so 25 by 56 mole of O2 will be formed from from 20 from 25 by 56 into 2, that is 50 by 56 mole of H2O2. So it means 50 by 56 mole of H2O2 is present in 1 liter of H2O2. Now the percentage strength of the H2O2 solution, that is given as, it is the mass of H2O2 in grams, the mass of H2O2 in grams divided by the volume of the solution, volume of the H2O2 solution in milliliters into 100%. So that we have to find. It means that in 100 ml of H2O2, how much mass of H2O2 is present? That is called as the percentage percentage strength of the H2O2 solution. Now here, now therefore 50 by 56 mole, 50 by 56 mole of H2O2, it means here we have 50 by 56 into molar mass of H2O2, that is 2 plus 16 to the 32, this much gram. So that will be equal to 50 by 56 into 34 gram. So that will be 17 to the 34, 17, no, 7, 2, so it will be 225 the 228 the 2 to the 4 to the 16, and then 2 14 the and 2 17 the 34. Okay. So this will be 25 into 17 divided by 30, divided by 14 gram, which is present in 1 liter of H2O2. Therefore, the percentage strength of H2O2 solution, that will be equal to 25 into 17 divided by 14 divided by 1 liter means 1000 ml into 100%. So that will be equal to 25 into 17 by 14 into 10, this much percent. So that will be 5 to the 10, 5 5 the 25, and 15, 7, 7, 5 17 the 85, and 35, okay, divided by 14 to the 28, this much percent. So which is approximately, okay, 25 by means 85 by 28. Divided by 28. So that is approximately 3.036%. So it is approximately 3%, I can tell. So the 3% is the percentage of the hydrogen peroxide solution. So option 2 is the correct answer. Then here it is told the decomposition of certain mass of CaCO3 gave 11.2 decimeter cube of CO2 gas at STP. So it will form calcium oxide plus CO2, and here it is told it gave 11.2 decimeter cube of CO2 and from a certain mass of CaCO3. The mass of KOH that is required to completely neutralize the gas. So now KOH will react with CO2 to give K2CO3 plus K2CO3 plus H2O. So here 2 KOH will react with CO2 to form K2CO3 plus H2O. The mass of KOH that is required to completely neutralize. So now we know that at STP, at STP, 1 mole of an ideal gas occupies 22.4 liter volume. So and 1 liter we know that is equal to 1 decimeter cube. So the amount of CO2 that is formed is 11.2 liters. Now, which means that it is equal to 11. Now, so therefore, the number of moles of CO2 that is formed, the number of moles of CO2 formed, that is equal to the the given the given volume divided by the molar volume of CO2, that is 22.4. So that is equal to 1 by 2 mole. So 0.5 mole. 0.5 mole of CO2 that will obviously react with 2 into 0.5 means 1 mole of KOH to form K2CO3 and H2O. So 1 mole of KOH is required to completely neutralize this gas. Now, therefore, simply we have to find the molar mass of KOH. Molar mass of KOH, potassium hydroxide. So for potassium, as we know, that is equal to 39 plus 1 plus 16. So that is 40 plus 16, that is 56 gram. So 56 gram of KOH will completely neutralize this half mole of CO2 gas. So option 1 is the correct answer. Then here it is told the density of gas is 1.964 gram per decimeter cube at 273 Kelvin and 76 centimeter of mercury, the gas is. So now 76 centimeter of mercury means it is 1 atmosphere. Therefore, the gas is what? Now we know that PV equals to nRT. Now the pressure is given as 1 atmosphere, and the volume is equal to V, suppose, and the number of moles we can say the given mass divided by molar mass times the ideal gas constant. We can write it as um, uh, in liter atmosphere, that is 0.0821 liter atmosphere per Kelvin per, per mole per Kelvin per mole. So into that is 273 Kelvin. Now here you can see this molar mass of the gas, we can say m by v into 0.0821 into 273. So this molar mass will come in gram. Since why here the density of the gas rho, that is mass by volume, that is given in gram per decimeter cube, means gram per liter, means it is 1.964 gram per liter. So therefore, the molar mass, that is uh, that is 1.964 into 0.0821 into 273, this much gram. So if we solve it, then we will get approximately 1.964 into 0.0821 into 273. So that is approximately 44 gram. So we know that 44 gram. Now the molar mass of CH4, that is 16 gram. Now molar mass of CO2 is 44 gram. Molar mass of C2H6, that is obviously 12 2s are 24 plus 6, that is 30 gram. And molar mass of xenon, that is obviously much higher. So it means the molar mass of CO2 is 44 grams. So therefore, the gas is CO2. The gas will be CO2 only. So option 3 is the correct answer. Then here it is told the formula mass of more salt is 392. More salt, we know, more salt, that is equal to actually ferrous sulfate dot ammonium sulfate NH4 whole 2 SO4 dot 6 H2O. It is called more salt, which is used as an alum. It is used as an alum, which is also called as ferrous ammonium sulfate, and it is a hydrated salt. So here it is told the iron present in it, it is in the +2 state, means it is in the ferrous state. So that is oxidized by KMnO4. It means it is oxidized to Fe3 plus, and KMnO4, that is MnO4 minus ion in the acidic solution, the acidic medium, uh, MnO4 will be reduced to Mn2 plus ion. The equivalent mass of more salt is. Now, therefore, the equivalent mass of more salt, that is equal to the molar mass of more salt divided by the valency factor of more salt. Now, here, since the more salt, the ferrous ion, which is coming from the more salt, that has to lose that has to lose that has to lose one electron, and MnO4 minus ion, that will lose or that will gain 5 electrons, since here Mn is in +7 state, +7 oxidation state. So here the valency factor for KMnO4, that is in the acidic medium, that will be equal to 5, and the valency factor for the more salt, that will be obviously 1 only. Now therefore the equivalent mass of more salt, that will be equal to the molar mass of more salt divided by the valency factor of the salt. So that is 392 divided by 1, which is same as 392 only. So option 1 is the correct answer. Then here it is told the number of gram molecules of chlorine in 6.02 into 10 power 25 hydrogen chloride molecules. So we have 6.02 into 10 power 25 HCl molecules. Now, therefore, here we have, so we know that in 1 mole of HCl, we have half moles of Cl2. Cl2 molecule can be formed. So it means we have half mole of gram molecules of chlorine. Half mole of gram molecules of chlorine. Now, therefore, 6.02 into 10 power 25 molecules, it means molecules of HCl, which means that it is 6.02 to 6.02 into 10 power 25 divided by the Avogadro number, which is 6.02 into 10 power 23, that is equal to 10 power 2, which is 100 moles, 100 moles of HCl. So it means that will have half into 100, means 50 gram molecules of chlorine. 50 gram molecules of chlorine it will have. So it means that option 2 is the correct answer. Then here it is told that then here it is told that which one of the following has maximum number of atoms of oxygen. Now 2 gram of water if I have, now 2 gram of H2O. H2O means its molar mass of H2O is 18 gram. Now it means it is 2 by 18 moles, that is 1 by 9 mole of H2O, and which will also contain 1 by 9 mole of oxygen, oxygen atoms. 1 by 9 means approximately uh, is 0.11 mole. 0.111 we can say mole. Okay. So, and in the second one, 2 gram of sulfur dioxide, 2 gram of SO2, it will have 2 by molar mass of SO2, that is 32 plus 16 to the 32, that is 64. So it is 2 by 64 mole, that is equal mole of SO2, which will also contain, so 2 by 64 means 1 by 32 moles. So it is 1, it also contains 1 by 32 into 2 moles of oxygen atoms. Since why 1 mole of SO2 will contain 2 moles of oxygen atoms. So 1 by 32 moles of SO2 will contain 1 by 32 into 2, that is 1 by 16 moles of oxygen atoms. In the third one, we have 2 gram of carbon dioxide, 2 gram of CO2. It means that it has 2 by 44 moles of CO2. That is 1 by 22 mole. 1 by 22 mole of CO2, that will also contain 1 by 22 into 2 moles of oxygen atom. Since 1 mole of CO2 contains 2 moles of oxygen atoms, so it will contain 1 by 11 moles of oxygen atoms. It will contain 1 by 2 moles of oxygen, sorry, 1 by 11 moles of oxygen atoms. And the fourth one, that is 2 gram of carbon monoxide, that will contain 2 by 14, no, 12 plus 16, that is 28. 2 by 28 mole of carbon monoxide, which will be same as 1 by 14 mole of oxygen atoms. So therefore, the maximum number of oxygen atoms is there in the 2 gram of water only, since it contains 1 by 9 mole. Since here the denominator is the least, therefore the value is the highest. The value of this fraction, it means here 1 by 9 is obviously higher than 1 by 11, and which is obviously higher than 1 by 14, and which is obviously higher than 1 by 16. Since when the denominator is the least, so the value of this fraction is the highest. So this fraction is maximum. So therefore, 2 gram of water has the maximum number of oxygen atoms. So it means that option 1 is the correct answer. And here it is told molarity of a given orthophosphoric acid is 3 molar. Its normality is molarity. Now, orthophosphoric acid means H3PO4, which is also called as phosphoric acid or orthophosphoric acid, and its molarity of the orthophosphoric acid that is equal to 3 molar. Its normality is. So now we know that normality that is equals to molarity of the acid times the valency factor of the acid. Now, valency factor of an acid is same as the basicity of the acid, which means how many H plus ions it can give. Now, H3PO4, as we know, it can give 3 H plus ions. So its valency factor is 3. So therefore, the normality of the acid of the orthophosphoric acid, that is the um, molarity of the orthophosphoric acid into 3. So that will be 3 molar into 3, that is equal to 9 normal. 9 normal is the normality of orthophosphoric acid. So option 4 is the correct answer. The gram molecular volume of oxygen at STP is. Now, gram molecular volume also means gram molecular volume also means the molar volume. We have to find the molar volume of oxygen. So now we know that molar volume of any ideal gas at STP is 22,400 centimeter cube. So therefore, the gram molecular volume of oxygen is also 22,400 centimeter cube, or I can say 22.4 liters or 22.4 decimeter cube. So it means option 2 is the correct answer. The mass of a metal, here it is told, the mass of a metal with equivalent mass 31.75 gram, it is the equivalent mass of the metal that can combine with 8 gram of oxygen is. Now here it is told that metal will combine with oxygen to give some metallic oxide. Let's say it is of the form MXOY. So it will combine with oxygen. So it means that here we can apply the law of equivalence. Here we can apply the law of equivalence. So according to the law of equivalence, we can say that the number of equivalents, of the of oxygen, that is equal to the number of equivalents of the metal. Number of equivalents of the metal. Now number of equivalents that is equal to, now number of equivalents that is obviously equal to the given mass divided by the equivalent mass. Now the number of equivalents of oxygen that is equal to the given mass, that is 8. The number of equivalents of oxygen that will be equal to 8 gram divided by the equivalent mass of oxygen. Now here oxygen will form oxide ion, will form 2 minus. So oxygen, so 2 moles of, so 2 oxygen atoms has to gain 4 electrons. It has to gain 4 electrons to form oxide ion. So the valency factor of oxygen that is equal to 4. Therefore, we also know that the the equivalent mass of oxygen, okay, so 8 by the equivalent mass of oxygen we have to use. Equivalent mass of oxygen is equal to the number of equivalents of the m- metal, that is the mass of that metal we have to find out, which will react with oxygen. So m by the equivalent mass of the metal is 31.75 gram. And now the um, equivalent mass of, yeah, so now the equivalent mass of oxygen, that will be equal to the molar mass of oxygen, molar mass of oxygen divided by the valency factor of oxygen, which is 4. Valency factor of oxygen is 4. Now the molar mass of oxygen is 32 gram, divided by the valency factor of oxygen is 4, that is equal to 8 gram. So therefore the 8 divided by the equivalent mass of oxygen is also 8, that is equal to the given the mass of the metal that will react divided by 31.75. So therefore m also will come 31.75 only. So 31.75 gram of the metal will react with 8 gram of oxygen. So option 1 is the correct answer. Then here it is told the volume of 10 normal HCl and 4 normal HCl that is required to make 1 liter of 7 normal HCl is. Now therefore here we can say that N1 V1 that should be equal to N2 V2. Simply it means the number of equivalents should be the same. It means the number of equivalents of here, let's say x ml, x liter of 10 normal is required and y liter of 4 normal is required to form 1 liter of 7 normal HCl. So it means that x into 10 that should be equal to 1 into 7, and also y into 4 that should be equal to 1 into 7. So it means x should be equal to 0.7. Okay. So to form 1 liter of HCl. Okay. Now here actually, okay. So if x liter of 10 normal HCl is used, then it means 1 minus x liter of 4 normal HCl should be used, since the total volume should be 1 liter only. Total volume should be 1 liter. So therefore N1 V1 plus N2 V2 that should be equal to N3 V3, I can say. So here x into 10 plus 1 minus x into 4 that should be equal to 1 into 7. So therefore 10x plus 4 minus 4x that is equal to 7. So therefore 6x that is equal to 3. So x should be equal to 3 by 6 that is equal to half. So that is 0.5. X is equal to 0.5. So it means 0.5 liters of HCl, 10 normal HCl is required, and 0.5 liter of 4 normal HCl is also required to form 1 liter of 7 normal HCl. So it means option 4 is the correct answer. Then here it is told carbon forms two oxides which has different compositions. As we know, carbon can form CO2 and CO. One is carbon monoxide and one is carbon dioxide. So the equivalent mass of which remains constant. So uh, here only the oxidation state of oxygen will change. No, o- here only the oxidation state of carbon will change, since here the oxidation state of oxygen is always -2 only. The oxidation state, the oxidation state of oxygen is always -2, but here the oxidation state of carbon is not same. The oxidation state of carbon in CO2 is +4, and oxidation state of carbon in carbon monoxide is +2. So therefore, the equivalent mass, as we know, equivalent mass equals to the molar mass, molar mass divided by valency factor. Now, since the valency factor of carbon is same as the oxidation state of carbon. So here, since the valency factor for carbon is not the same, so the equivalent mass of carbon is also not same. Equivalent mass of carbon is not same, but since the valency factor for oxygen is the same, since the valency factor of oxygen will be 2 only, so the equivalent mass of oxygen will remain the same. So option 2 is the correct answer. Then here it is told a gas at a pressure of 2 atmosphere. There is a gas whose pressure is 2 atmosphere. It is heated. It is heated from temperature T equal to 25 degrees Celsius, means 298 Kelvin, to a temperature 323 Kelvin, means 323 plus 273, that is equal to 596 596 Kelvin. Uh, so this is the initial pressure, and the initial volume is suppose V, and then the final volume is 2V by 3, means it is simultaneously compressed to 2 by 3 of the original value, 2/3 of the original value. Then the final pressure is, we have to find out the final pressure here. So now here the number of moles will be constant only, so we know that PV equals to nRT. So it means the number of moles is constant, so I can say PV by T will be equal to constant. So therefore P initial V initial by T initial, that is equals, so this one is T initial, this one is T final. T initial is 298 Kelvin, which is 273 plus 25, 273 plus 25 degree Celsius, and this is equal to P final V final by T finals. So therefore P initial is equal to 2 atmosphere divided by into V initial, that is V, divided by T initial, that is 298, equals to P final, we have to find out, into V final, that is 2V by 3, divided by T final, that is 596. So we know that now 298 into 2, if I do, that will come 2, 8 is 16, 2 9 is 18, 19, 2 4 5. Okay, so it is 596. So it means T final is 2 times of T initial. So this is equal to 2. Now 2 and 2 will cancel, V and V will cancel. So that's why, therefore, it is coming P final by 6. P final by 6, that is equal to 1. So it means P final is 6 atmosphere. So option D is the correct answer. So the final pressure of the gas is 6 atmosphere. Then here it is told a 30% solution of hydrogen peroxide is. So 30% solution, it means that 30 gram of hydrogen peroxide is present in 100 ml of the solution. So now, therefore, now H2O2, that will give 2 moles of H2O2, that will give 2 moles of H2O plus 1 mole of oxygen. Now 30 gram of H2O2, if I have 30 gram of H2O2, so how much mass of uh, how much liter of oxygen it will give at STP, that we have to find out. So now so here we see that 2 moles of H2O2 hydrogen peroxide will give 1 mole of oxygen gas, O2 gas at STP. So now therefore 30 gram of H2O2 means how many moles of H2O2 that we have to find. So 30 gram divided by the molar mass of H2O2, that is 2 plus 16 to the 32, that is 34. So this much mole of H2O2, that is 30 by 34 mole, or I can say 15 by 17. 15 by 17, 7 to 15 to 30, 17 to 34. Okay, 15 by 17 mole of H2O2. So therefore now 15 by 17 mole, 15 by 17 mole of H2O2, that will give uh, 15 by 17. So half of that, it will be 15 by 34 mole of oxygen gas it will give. So now therefore 1 mole of oxygen gas occupies 22.4 liter at STP. Now, so 15 by 34 mole of O2 will occupy 15 by 34 mole of O2 will occupy 15 by 34 into 22.4 liter at STP. So now, therefore, here you can see that 30 gram is present in 100 ml. So from here we can see that 100 ml, so 100 ml of H2O2 will give 15 into 22.4 by 34 liter of oxygen at STP. So it means 1 liter of H2O2, that will give how much? 1 liter means 1000 ml. So it will give 15 into 22.4 by 34 into 10. Into 10 liter of O2 at STP. Now this value will be how much? Approximately, that is 15 into 22.4 by no 15 into 224, 15 into 224 divided by 34 liter of O2. So that will give you approximately 15 into 224 divided by 34. So that is 98.8. So it is coming approximately 98.82 liter of O2. So which is approximately, I can tell, 100 liter of O2. So 1 liter of H2O2 will give approximately 100 liter of O2 at STP. So therefore we can say that 100 means 30%, if it is the percentage strength, 30% strength of H2O2 solution, it means so it means 1 liter of H2O2 will give 100 liter of O2. It means it will be called 100 volume H2O2 solution. So option B is the correct answer. So hope all of you have understood the solutions of all these questions based on the chapter Some Basic Concepts of Chemistry on the previous year KCT exam. Still, any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Mm, uh, and also, please install our Sapience Education application, where we shall upload some important homework questions based on the previous year KCT exam, which shall be obviously helpful for your exam. So, thank you, everyone. Bye.